Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving headfirst into the exciting world of micro-budget AI image generation. Specifically, Sony researches groundbreaking work on training large-scale diffusion models without breaking the bank. It's mind-blowing.
Whoa, micro-budget AI? That sounds intriguing. I'm all ears. What's the big deal?
The big deal, my friend, is that Sony managed to train a 1.16 billion parameter sparse transformer diffusion model for a measly $1,890. Can you believe it? They used just 37 million images, a mix of real and synthetic, and achieved a Friche inception distance, FID, score of 12.7 on the COCO dataset. That's seriously impressive for such a low budget.
An FID of 12.7? For those of us not steeped in image generation metrics, how good is that, really?
Think of FID as a measure of how realistic and diverse the generated images are. A lower FID is better. 12.7 is exceptionally good, especially considering the budget. It's practically on par with models trained with significantly more resources. It's like baking a Michelin star cake with only ingredients from your local dollar store.
Amazing! So how did they pull off this feat of frugal AI wizardry?
They cleverly employed a few techniques. First, they used a sparse transformer architecture, which is more efficient than some other models. Second, they used a progressive training approach, starting with lower resolution images and gradually increasing the resolution. And third, they incorporated a smart patch masking strategy during training, which significantly sped things up. They even provide the code to reproduce their results.
Patch masking? Explain that like I'm 5, or like I'm a slightly less technically inclined podcast listener.
Okay, imagine you're coloring a picture. Patch masking is like covering parts of the picture while you color the rest. The model learns to fill in the missing parts, and this process makes it more efficient. They masked 75% of the patches during the initial training phases, then fine-tuned it with no masking to improve performance. It's a clever way to accelerate training without sacrificing too much quality.
I see. So it's all about clever optimization and efficient techniques. But what about the data? 37 million images still sounds like a lot to gather.
That's true. But they cleverly leveraged a combination of publicly available real images and synthetic images. Their GitHub repo even provides instructions for downloading and pre-processing the data, which is super helpful for reproducibility. They even suggest starting with a small subset of the data for initial experimentation to save time and resources.
That's excellent for researchers with limited resources. It makes the whole process much more accessible. And what about the actual training process? How long did it take?
The entire training process, from start to finish, took about 2.6 days on an 8xH100 machine. They break it down into 4 distinct steps, each with its own configuration files, which are all available on the GitHub repository. They even provide pre-trained model checkpoints on Hugging Face, so you don't have to train from scratch if you just want to experiment with the models.
This is fantastic. It really democratizes access to advanced image generation techniques. It's not just about the low cost, but also the ease of reproduction and the readily available pre-trained models. This is a game changer, isn't it?
Absolutely. It opens up a world of possibilities for researchers and hobbyists alike. The fact that they've made their code, data, and models publicly available under the Apache 2.0 license is a testament to their commitment to open science. This research truly pushes the boundaries of what's possible with limited resources. And that, my friends, is something to celebrate.
Couldn't agree more. Thanks for breaking down this amazing research for us. It's truly inspiring to see what can be achieved with ingenuity and a little bit of cleverness.
My pleasure. And that's all the time we have for today's episode of Tech Bytes and News. Join us again tomorrow for another exciting deep dive into the world of tech. Goodbye.
Bye-bye.